Okay, so we're going to go over this family tree of quadrilaterals. Now, when you see quadrilaterals, you should think 4, because when you see quad, that's a 4-wheeler. Anytime you see quad, it's 4. So these are 4-sided shape. Any 4-sided shape is called a quadrilateral. Now, there's more than just 2 branches of quadrilaterals. You've got random quadrilaterals. Any 4-sided shape is considered a quadrilateral. But we're going to branch these off into 2 specific sections based on parallel sides. So, first of all, if there's just one set of parallel sides, as we just talked about, this is called a trapezoid. So the top and the bottom run the exact same direction. Even if I extended them, they're never going to cross. But these other sides, the left and the right, if you extended these, they're going to cross eventually. So these are not parallel. So if I was labeling the parallel sides, it would be these 2. These are not parallel. Now over here, I've got 2 sets that are parallel. The top and the bottom. They're parallel to each other. Even if I extend them, they're never going to cross. But these other sides, the left and the right, are also parallel. If I extend those, they're never going to cross. So they have 2 sets of parallel sides. Now if I wanted to label these other sides, I can't put one little arrow because that means I'm telling you they're parallel to these sides. So I'm still using arrows, but I got to use a different number of arrows to show that these are parallel and then these are parallel. Wouldn't make sense to give them all one arrow because that would mean they're all parallel to each other, which clearly isn't true. So quadrilaterals can be split into these 2 groups based on parallel sides. Trapezoids, 1 set. Parallelograms, 2. So any quadrilateral that has 2 sets of parallel sides can be classified as a parallelogram, which means all of these shapes underneath of this are parallelograms and are also quadrilaterals. Everything you see underneath of this is quadrilateral. They're all 4-sided shapes. So all of these underneath here are also all parallelograms because they have 2 sets of parallel sides. So this shape here has parallel sides on the top and parallel sides left and right. Same here. Top and bottom are parallel. Left and right are parallel. Top and bottom are parallel. Left and right are parallel. That's how come these are all parallelograms. Now we're going to write the names in each one of these. You can kind of see the way this worksheet was made. You're supposed to put the name inside the dotted line. I don't like how they took these out, so we're just going to cross those out. We're only worried about these 3 shapes. These are just supposed to be for the names of them, but we can fit them inside. So parallelograms now can be split into 2 different pieces. They can have 4 90-degree angles. So if you notice, all the corners here are 90 degrees, and we know that this is a rectangle. They could also have 4 equal sides. So all the sides here are the exact same length, and that's called a rhombus. So a rectangle is a parallelogram because it has 2 sets of parallel sides, but it's more specific because it has 4 90-degree angles. Same thing with the rhombus. It's a parallelogram because of the parallel sides, but it's more specific than that. Since all the sides are equal, we call it a rhombus. Now what if both things are true? 4 90s, 4 equal sides, we know this is called a square. So if it has 4 sides, it's a quadrilateral. 2 sets of parallel sides, it's a parallelogram. If that parallelogram has 4 90-degree angles, it's considered a rectangle. If it has 4 equal sides, it's considered a rhombus. If it has both 4 90-degree angles and 4 equal sides, it's a square. So 4 90s, and all the sides are equal, which means a square is a rectangle because it's a parallelogram with 4 90-degree angles. So a square is a rectangle. Every square is a rectangle. Every square is also a rhombus because it has 4 equal sides. Every square is a parallelogram because it has 2 sets of parallel sides, and every square is a quadrilateral because it has 4 sides. So square falls under all of this. Let's answer these. True or false? Every square is a rectangle. Yes. The square is underneath the rectangle. This is true. Every square is a rectangle. A lot of people think they're totally different. They're not. A square is a rectangle. Now, is every rectangle a square? No. Here's a rectangle right here. That's not a square. Okay, so some rectangles are squares if they have all equal sides. A rectangle can have all equal sides. It's called a square. But a rectangle does not have to have all equal sides. So not every rectangle is a square. Is every square a rhombus? Yes, because a rhombus just means it's a parallelogram with 4 equal sides, and a square is that. But is every rhombus a square? No. A rhombus can be a square. So if it's a rhombus, it has 4 equal sides. If you give it 4 90s, now it's a square. Okay, but if it doesn't have 4 90s like this one, it's not a square. So sometimes a rhombus is a square, but sometimes it's not. Is every parallelogram a rectangle? Well, no, because we can branch off this way, or you can just look at this parallelogram. It's not a rectangle. So parallelograms don't have to have 90-degree angles. They can, so sometimes it's a rectangle, but they don't have to. Is every trapezoid a parallelogram? No, that's false. A trapezoid is never a parallelogram, because to be a parallelogram, it's got to have 2 sets parallel sides. Trapezoid's only got 1. Is every rhombus a parallelogram? Yes, it falls underneath of that. That's true. It's true because a rhombus always has 2 sets of parallel sides, so it's always a parallelogram. Are all parallelograms quadrilaterals? Basically, it's asking you, do all parallelograms have 4 sides? Yes. It's always true. You don't have a parallelogram with more than 2 sides or less than 2 sides. And these last 2 are kind of repeats, just worded differently. Are all parallelograms rectangles? No. Here's one that's not. That's false. Sometimes they are, sometimes they're not. And then are all trapezoids parallelograms? No, they're actually never parallelograms. Okay, so now the important part. How do I solve for the area of all these different shapes, and how do I show my work? So for each one of these, you're going to show 3 lines of work. At least. Sometimes you may want to show more, but that's the minimum. You have to have at least 3 lines of work. And I'm going to be very specific about what those lines need to look like. Okay, your first line is always going to be the formula. You're going to write down the actual formula. So for this one, line 1, this is a parallelogram. It's a rectangle, but it's a parallelogram. So if you look back to your notes on the other side, the formula is area equals base times height. So line 1, you just write down the formula with the letters. Line 2, replace the letters, or plug in. So the base and the height are 5 and 6.9. So before I actually multiply them in my calculator, I'm going to replace them. So base is 5, height is 6.9. You don't have to show multiplication with parentheses, but if you're going to use a dot, and we're dealing with decimals, it can get a little confusing. What's a decimal, what's a dot for multiplication? So I suggest you use parentheses to show multiplication, but you don't have to. Okay, now you simply multiply them across, so you get your answer on the 3rd line. So area equals 34.5. Now, we do want to start talking about units here. We're talking about miles in this particular case. So the answer is going to be in miles, but not just regular miles. Miles squared to the 2nd power. So when you multiply miles times miles, you get square miles, or miles to the 2nd power. That's going to be true for all area. So anytime we get area, it's going to be square miles, square inches, square feet, okay, to the 2nd power. It's going to be every single time we find areas to the 2nd power. All right, number 2. This one's a trapezoid. Parallel line on top, parallel line on the bottom. Okay, so these are not parallel, these are formula from the other side, 1/2 base 1 base 2 times the height. First line, write the formula. Second line, replace. So we're not doing any adding and subtracting or multiplying on this line. We're just replacing the numbers. So the half stays. B1 and B2 are these 2 numbers. It's always the parallel lines. Those are your bases, the 2 sides that are parallel. It does not matter which one you call base 1 and base 2, so I'm just going to put them in any order. And then the height is always the distance between those 2. The distance between those 2 parallel lines, you're always going to see a 90 degrees on the height, so it's 2.4. Notice this 5.8, never used it. It's just the length of this side, and you don't use that number to calculate anything for the area. So you need to sometimes not use numbers that you see. You can't just grab every number and try and use it. Now, if you try and plug this all in your calculator, you're probably going to get the wrong answer. Okay, you have to put parentheses. Now, if you know how to put parentheses into your calculator, then you can get this to work out if you plug this all in. My suggestion, though, is that you do this separately. Parentheses mean you have to do this first. If you don't tell your calculator to do this first by putting parentheses, it won't, because it's going to follow the order of operations. So your calculator is going to multiply first and then add if you don't put the parentheses. Again, instead of trying to plug all of this in at once, I suggest you just do this first. So if you put these together, it's 11.2. So we're going to have one extra line here. Now it's pretty easy to do. A couple ways you can plug this in. You can change 1/2 to 0.5, and then it's just 0.5 times 11.2 times 2.4. That'll work. You also can do this last. Multiplication can be done in any order, and you still get the right answer. So you could multiply these two first, and then take half, which could be multiplying by 0.5. But the other way to take half is divide by 2. So you could multiply these together and then divide by 2. When these are nice numbers and you can just do them in your head, that's probably the easiest way to do it. Multiply and then divide by 2. But if you just plug it all in, 0.5 times 11.2 times 2.4, we get 13.44 units. Our feet, area is always to the second power. So 13.44 square feet, or feet squared. Okay, number 3, a triangle. I'm going to run through these fast now. 1/2 base times height. I've got a bunch of numbers in the picture. I've got to choose the base and the height. The key is the 90 degrees. The base and the height always hit at 90 degrees. So area equals 1/2. The base is 7.8. The height is not measured on a slant. When you're measured at the doctor or measuring anytime, you don't measure diagonally to the floor. You go straight down 90 degrees. So the height is 3.5. So to multiply these, you can do 0.5 times this, or you can multiply these two together and then divide by 2. That runs out to 13.65 meters. Oops, I said miles. Meters squared. Jump quick to number 6, also a triangle, so 1/2 base times height. Now here's one where the base is not on the bottom. You got to look for your 90. That tells you your height, so the height is 5. So this h is going to become a 5. Now the base and the height have to hit at 90 degrees. This 12 is not hitting the 5 at 90 degrees. We don't know this angle. What we do know is that 5 is hitting this side at 90. It's the two sides of the box that you have, 5 and 6. Now this whole length all the way out to this isn't 6. We're just talking about the base of the triangle. So the base is actually 6. So it's 1/2 times 6 times 5. So this is where it can get a little tricky because we want the base to be the bottom. If the height's being measured to a different side, then this is not the base. Now it's possible to drop the height to this base. But if it's not, these are your two numbers. So this is one you could do in your head. 6 times 5 is 30. Take half. It's 15 centimeters squared. All right, last one I want to do here is the circle. So if you grab your circle formula, it's area equals pi r squared. R is halfway across the circle, which is what's given here. So the only thing we need to replace is r. So r becomes 5, and it's squared. Now sometimes they're going to give you the distance all the way across. They're going to give you one number for all the way across. In this case, it would be 10, because if this is 5, this also has to be 5. The radius is the same in every direction. You could draw another one, and it's 5. They're all 5. So if you extend it all the way across, it's 5 and 5, it's 10. So if they were giving you 10 all the way across, you can't plug 10 in here. You have to take half of it and get 5. Now 5 squared, if we leave pi alone for a second, 5 squared is not 10. It's 5 times 5. It's 25. So just a reminder, you could do that in your calculator. So you're going to use the little squared button right here. 5, hit that. Raise to the second is 25. Now pi has its own button. It's right here. So you're going to do pi times 25. Now pi is a nasty decimal, so when you multiply with it, you get more nasty decimals. So we're going to round these. 78.5. We'll go nearest tenth. So 78.5. The 3 tells you to leave it alone. So it's 78.5 meters squared. You also, before you got the 25, you could have just did pi times 5 raised to the second, and you'll get the same answer. So you don't have to actually expand that. You can do this in 3 lines, but 4 is fine. Remember, 3 lines for all of these is the minimum.